Hi everyone. Today I'm gonna explain about my data science experiment, fourth experiment. Uh, yeah, here comes first one. This is about this sample mean for price n equal to 40 repeated three times per fuel type. In here, a sample size is n is equal to 40. A fuel type is used to separate a petrol, diesel, or etc. like a fuel experiments, and a sample that randomly select a 40 prices, and a mean calculates the average price of the select sample. And the import keywords I have used here a sample, a mean to find the all of this, and fuel type and price and n equal to 40 and a random state. And this is my output. And second one is about sample mean for price n equal to 80 versus n equal to 40. In here, two different sample sizes are used, 40 and 80. A same fuel type is considered separately. Sample 40 selects 40 observations and sample 80 selects 80 observations. The experiment show that effect of sample size in the sample mean. Here I have used a sample size n equal to 40 and n equal to 80, mean, random, and sampling are the keywords used here. And this is the output for the second one. And the third one is about a population mean of price per fuel type. Here, it calculates the average price of all available costs of each fuel type. Like a population means use all available observations, group by fuel type, separate the cost according to fuel type. Price dot mean that calculates the average price, and unlike a sample mean, it uses the complete available data. A result gives the average price for each category. And here comes the output for third one. And fourth one is about a 95% confidence interval n is equal to 40. In here, it calculate a 95% of confidence interval for the population mean using the sample of 40. Means a confidence interval gives a range of a possible value for a population mean. The sample size is 40 and a start.sim that calculates a standard error of the mean, and a states dot t dot intervals that calculate the confidence interval. And it check whether the actual population mean falls inside the calculated interval. And here comes the output for fourth one. And a fifth one is about a 99% of confidence interval versus 95%. We want to comparison in this fifth experiment, and it compares the width of 95% and 99% confidence intervals. Here, both interval use the same sample of 40, and a 95% confidence level gives a narrow interval. A 99% confidence level gives a wider interval, and a higher confidence requires a wide range. And the experiment demonstrate the relationship between a confidence level and the interval width. And this is the output for fifth one. And the sixth one is about a plot 25 confidence intervals, n equal to 40, and using petrol as available in the data summary. In the sixth question, it create 25 different 95% confidence intervals using different random samples of a 40 petrol cost. Here, the experiment uses a petrol fuel type. It create a 25 different samples. Each sample contain 40 observations, and a 95% of confidence interval is calculated for the each sample. A graph shows which intervals contain the population mean. Here is the output for sixth one. And the seventh one is about to measure the relationship between a core age and the price. Person correlation measure the linear relationship between the two numerical variables. Here the variables are age and price. A Pearson calculates the correlation coefficient, and the correlation value ranges from -1 to +1. Positive means both variables tend to increase together, and negative means one tend to decrease as the other increase. And here's the output. The eighth one is about a Spearman rank correlation, Km versus price. Means a Spearman correlation is based on a rank or order of values. It is useful when the relationship may not be perfectly linear. Here, Km and price are compared. So, a Spearman calculates a Spearman correlation, and a code also calculates a Pearson correlation for a comparison. Here's the output for eighth one. And the next one comes a ninth one, that covariance matrix. It calculates a covariance between the several Toyota car variables. In here, we have used a variable used price, age, km, hp, cc, weight, and a covariance measures how two variables change each other, like together. Data.cov that calculates a covariance matrix, and the positive covariance means variable tend to increase together, and negative covariance means one tends to increase when other is decrease. The matrix contains covariance value for every pair of variables. And here comes the ninth one output. And 10th one is about test a climb that an average car price is at 12,000. Given population mean 12,000 and standard deviation 2,500 and sample size 50 and sample mean 12,750 and significance level are 0.05. A z-test is used to test a population mean when the population standard deviation is known. Null hypothesis mu is equal to 12,000 and alternative hypothesis is equal to greater than 12,000. A z-score is calculated using the sample mean, a population mean, and a standard deviation of the sample price. And if p-value is less than 0.05, we reject a null hypothesis. And we have some formulas for this. And here comes the output for 10th one. Thank you, friend.